Hi friends, we're back. I'm on page 2. We just talked about angular kinematics, and now we have to take a little break from relating things that we know to talk about something new. So this new idea is torque. We use the Greek symbol tau, and torque is just any force that is causing a rotation. And so if this was a door, a hammer, a wrench, anything like that, and I apply a force some distance from my axis of rotation, I'm going to get some rotation, right? It's going to go round and round and round. This could be like the hands on a clock. This could be really anything. And so torque is just that force that causes rotation. And there are two equations we have for torque. We have force times length times sine of theta, and that theta is the angle between the length that we're talking about and the force. So it would be right here. So this one happens to be perpendicular. This other equation is actually the same, and I'm going to talk about what that looks like, but it's force times R, which is a lever arm. And the lever arm is defined as the perpendicular distance from the axis of rotation to wherever the force is being applied. And so in this case here, the length of my object that is rotating, because this is my axis, here's my force, is actually equal to the lever arm because my force is already perpendicular. That's great if my angle is 90 degrees. So we're saying that the length times sine of theta of our angle is going to be equal to the lever arm. So this piece actually is just the definition of lever arm. So if you want to think about torque as lever arm times force, that's fine. Or you can think about it as length times sine of theta, because if you notice, here's my force being applied at some angle of 40 degrees. My lever arm has to be perpendicular to whatever object is rotating. And so here's my lever arm, here's my perpendicular. And if I use trig to figure out what the value of R was, well, that is my opposite leg. And so in order to find that, it would be sine of theta. And so we're taking our force times sine of theta times the length. And if we rearrange all of those, we come up with this question. Force times sine of theta times the length gives us our equation for torque. So essentially, L sine theta is just telling you how to calculate the lever arm, because by definition it's perpendicular. Sine of theta will always give you the perpendicular leg to this object. So how do we find torque then? Well, torque is a force. We know here it's 35 newtons times a length, 25 centimeters, times the angle to give us the perpendicular distance between the force and the length, so it's sine 40. Right? If you want to think about it in terms of the lever arm, you would have to physically find what is R, and it's force 35 times sine of 40 times the length. Right? And so we would end up with the same equation. Now there are some practice problems here. I've gone ahead and drawn in the lever arm every time, just so you can kind of see what it is. This one happens to be the same as what we just did. Here, we can think about these as doors. We're applying a force this way, and honestly, maybe it's better to see it up here, but you know if you went to the edge of the door and you pushed in, that door's not going to rotate. And so that's why we have this idea of the perpendicular distance, because only the perpendicular part of the force is going to be giving us some rotation. And so that's why that equation is that way. And so if my force is this way, this actually is my lever arm, but I can again just say torque is equal to force times the length sine of theta. Because that will give me my lever arm value. Over here, we have to be a little careful with our angle. Our force is being applied this way to the door. And so if we want the perpendicular lever arm, we're pushing this way, which means we want whatever this angle is right here. And so we know that perpendicular is going to give us an angle of 40. All right, so you should probably be doing these before you're watching me do them, because you're not going to retain any of this information if you don't. Here's the next one. We have 3D, but again, it's force times length sine theta, and we end up with 50 times 0.1 sine of 60. Woohoo. One note, unit for torque is Newton times meter. That's because lever arm is, oops, can't see that. Lever arm is a distance, force is a Newton. So you're set.